Let's look at a functional solution now to the problem that we presented in the previous video. So here was our non-functional solution, right? So we had variables here, and remember that the task was to get from an input text, get the words, the unique words in alphabetical order, and assign a number that kind of gave the alphabetical order, starting with 0 with the first one, and so on. So the variables and then the loop. So those two together means this solution is non-functional. Functional solutions do not have variables or loops. Here is the solution to that same problem in a functional method. So we start with our input text, and then we have one line of code that is doing the same thing as our previous code. And this is a functional solution, right? There's no loops, there's no variables. All we have here are function calls, which is what pretty much functional programming is, at least in absence of loops and variables. Let's look at this a little bit closely just to make sure we can see everything that's here. And most of this is self-explanatory. Remember that we're working from inside out of the parentheses. So we're going to start here. We take our input text, we split it into a list, we make that into a set, which will get our unique list. Then that returns a set, which is going to be fed into the list function, which will make it something that can be ordered. Sets aren't ordered. That will return a list, which will be fed into our sorted function. Our sorted function will be fed into this zip function, which actually has two arguments. A little bit hard to see with all the parentheses trying to follow it, but zip has this sorted list as its first argument, and its second argument is here. And if we work from inside out, we'll see that we start with our list of words, again, get the unique set of words, return that to our list function, so it's a list, and then we can get the length of that list, which is fed into range. So what we're going to end up with, since we know the range function, is a list of numbers from 0 onward that is the same length as our sorted list of unique words. And that's the two arguments for zip. Both of those being fed into zip. Zip will return something that is going to be fed into dict. So we're going to get a dictionary at the end. All right, so that's all the components. Let's take this apart and look at it a little bit closer. Before we look at it, there is one thing that we need to know. So there's one thing that we haven't learned yet that will really help us as a function call to be able to do what we need to do. We know how to do the splitting, getting the unique words, getting the list and sorting it. But we also, without a loop, somehow we need to combine together or kind of pair up each word and each number. So let's write a function called pair up that's going to take two lists. And obviously it's eventually with the idea of taking a list of words and a list of numbers and pairing them up. And we'll combine them into pairs as a list of tuples. So each tuple will hold a word and a list. So we want a function called pair up that's going to take these two arguments. So here's a toy example, a list of numbers and a list of letters. And it's going to pair them up into tuples and put those tuples in a list. So here's how we could write this using what we know so far. Here's our pair up function with two arguments. We'll start with our list. We'll declare a list variable with an empty list. And then we're going to loop over, we're going to get a list of numbers or an iteration of numbers from range. And we're going to loop over those numbers. And we're going to get this from list 1. And we're going to say if that number is greater than or equal to the length of the list 2, and the length is going to be the number of items, right? So once I is greater than or equal to the number of items in list 2, we're going to break out of this loop, which will take us down to a return statement. So in other words, if the lists aren't the same length, as soon as if list 1 is longer, as soon as it reaches the last element in list 2, it's going to stop. We're not going to try to pair up the extra element in the list. But as long as we have the same number of items in the list, we're going to take the first, or the ith item from list 1, and we're going to pair it with the ith item in list 2 and append that to our empty list that we started. So we're going to end up with this list of tuples. So the 0 item in list 1 is going to be paired up with the 0 item in list 2, the 1th item with the 1th item, and so on and so forth. It's exactly what we need. So we can think about how we would use this if we could get a list of our words and then the list of numbers starting with 0, and we could pair them up, then we would have those numbers that would give us the order of the vocabulary. Something we can do, something we have all the tools we need to do that in this way, which is not a functional way, right? We were declaring a variable and we've got a loop, so it's obviously not functional. We can do this in a functional way. So let's try it out. We actually have everything we need to do the same thing, but in a functional way and with a functional solution. So again, what we're trying to do is build a function called pairup that's going to take the corresponding elements in 2 lists and pair them up into a list of tuples like this. Okay, so here's a functional solution. And as you might expect, this is a recursive function. So let's look at this a little bit closer. So again, this is something that you could do already very easily. Notice that there's no variables and no loops. And of course, when we think about a recursive function, the first thing is to think about how to break this down into smaller parts. And what we've got here is what we've done, the small parts, is taking if you take the first element out of a list and pair them, we take them out of those 2 lists, then then you can go and take the first elements out of the list that's left and pair them, and then take the first elements out and pair them, and you're gradually reducing your list, and you're always taking the first element and pairing them. And you can concatenate, if you pair them in a tuple and put them in a list, and you concatenate all those lists together, and you get a long list of tuples. So that's what this recursive function is doing, using the stack, of course, and this breaking down. So it's going to start with pairing the first element in our list, and then it's going to do this recursive call with the list minus the first elements in both of the lists, which will then the first element will be paired up and reduce the length of the list and pair up the first element, and so on and so forth, until either list 1 or list 2 is empty. So when the length of either of them gets to 0, we're going to stop. That's our base case. We don't want to do any more pairing, ignore any extra items, and we'll return this empty list. And the empty list will get concatenated to the previous pairing, which would have been the last element of the list, and that would be concatenated with the previous, and so on and so forth. We'll return up the stack until we have this long list of tuples. So this is a functional solution to our helper function. And you could write this function either way. You're perfectly capable of it. Fortunately for you, and it's actually quite easy to write functionally as well. And actually, if you look at this, so this is an interesting thing to look at. You could do both of these ways, but you can see that actually the recursive function is a lot cleaner, it's a lot shorter. And if you have a good grasp of understanding of how the stack and the return statements work, it's easier to write functionally than non-functionally. Actually, you don't have to use the break statement, you don't have to go through the loop and figure out the pairing of the numbers, just break it down to small pieces and use a recursive function. And you could do either way. Fortunately for you, you don't have to write this function. Python already has such a function built in, and it's called the zip function. So it does exactly what we just saw with our made up pairup function. So if we feed it the zip function to list, it will give us back our list of tuples paired. And you notice here that we have to, well, in this case, what we're doing to get this list, we're getting the zip function and then we're casting it to a list. And we have to turn it into a list. We have to cast it to a list with the list function in order to print it out and see it as a list, if that's what we want to do, because Python returns an iterator from the zip function. It's not a list. And we've seen the same thing. We've looked at what an iterator is a little bit. It's something that you can loop over, but it's not necessarily a list, it's not a set, it's not a dictionary. It's creating this thing that you can loop over. And then it's very similar to what happens with range. And it's great for using in loops, but if you want to see it and print it out or save it, you cast it as a list, okay? So we've seen that. So that's how zip and range are similar in that function, in that way. All right, so now that we have our helper function, let's go on and solve our problem that we had, taking our input of text and building a program. In this case, we want to build a functional program that's going to return a dictionary with the words as keys and numbers indicating the alphabetical ordering as its values. So we saw how to do that functionally. It was a very long line of code. I've taken that same line of code, and now that we've looked at the zip function and how you can build that, we understand everything that's going on here. But what I've done is I've actually split it into 2 lines just to make it a little bit easier to read. So this actually isn't very functional because we're using a variable here, but it's a little bit easier to read to kind of split up what's going on. So this line right here is taking our list, our string, and turning it into a list of words. It's returning that to the function as an argument, the function set, which will take that list and get out the unique items. That set is being returned as an argument to list, which will turn that set of unique words into a list, and then pass that list to the function sorted, which can now sort the list, since a list can be sorted. So the vocabulary variable is a sorted list of unique words from our string. So we have a list of words, which we can now pass as the first argument to zip, and then we want to pair those list of words with a list of numbers starting with 0. And to get that, we can use the range function, right? It's a very easy way. We get our vocabulary, get the length, which is going to give us, 8 words, and then range will produce something like a list of numbers starting with 0 and ending at 7, and zip will pair each one. The numbers are in order starting with 0, and our words are in order, so we're going to get the correct pairing with brown to 0 all the way to the with 7. So that's going to give us a list, or actually an iterator of tuples, which we can then pass as an argument to the dict function, which will convert that list, if you will, the iterator of tuples, into a dictionary, pairing each element in the tuple as key and value. And we'll get the output that we want. So that's a functional solution. It's much, much more compact than our original solution, or non-functional solution, which, not counting our input text, has 1, 2, 3, 4, 5, 6 lines of code, versus this one is split up into 2, but if we did it as we had it in the original slide, it would just be 1 line of code, right? That's much, much more compact. Right, here we have it. Actually, we can take those 2 lines and make that 1 line of code. So the functional solution, if you count our input text, we've got 2 lines of code versus the 7 lines of code in our non-functional solution. It's much, much more compact. However, which one do you think is more readable here? I don't know about you, but I definitely find the non-functional solution down here much more readable than the functional solution. It's much easier to track what our steps is. It goes line by line by line, versus trying to work outwards from parentheses and keep track of how many closing parentheses we have so that we know which is going with which. This is much less compact, but much more readable. So this fact, this compact versus readable, illustrates a problem with going all in functional. Functional is more compact, but it's much less readable. And Python programmers prefer readability over everything else. So Python, which is not a functional program, but has a lot of elements of functional programming, makes a little bit of trade-off. Mainly non-functional, but it's going to use functional techniques, and a good Python programmer will implement functional techniques in 2 situations. First of all, when a functional technique shortens the code, it makes it more compact significantly and makes it more readable. So those are the 2 times when you will use a functional technique. And of course, as we saw, you can shorten the code and make it much less readable. So you have this trade-off between the two, shortening your code, saving yourself some lines of code, and making it more readable. And actually, readable is a subjective thing, right? What's readable to you may not be readable to someone else. Functional programming in Python can be much more readable, but only if you're familiar with it. If you're not familiar with it, it's going to be hard to read. So in order to be able to make this trade-off and be a good Pythonic programmer, you need to learn some idioms of the functional style in Python. And once you learn those idioms and start using them, you're also going to get better at reading such code. So you're going to be able to use these functional programming techniques in a way that will shorten your code and make it more readable, and also be able to read other people's functional techniques. So in another video, we're going to look at a couple of very common idioms of Python's functional style that will make the code, once you learn these idioms, more readable and more compact, and also a lot of fun to write.